Alright, welcome back, Honors Algebra 2. Hopefully you guys did well on your test yesterday. Today we're going to start, or tonight you're going to start looking at Chapter 3 stuff. A lot of this should be review. We're starting off with talking about what a system of equation is. You guys should have learned that in Algebra 1. Basically what a system is, it's two or more variables. So you'll have x's and y's or more. We're actually going to deal this year with we're going to deal with three equations and three variables. So two or more equations in two or more variables. Alright, so a solution set is basically the ordered pair or the point. Okay, so sometimes we give our answer as a coordinate. So x comma y, you don't have to say x equals y equals. I want it as an ordered pair if I ask for it. It's an ordered pair that satisfies the equation. Actually, it satisfies both equations. Okay, so which means if you plug it in, it'll work in both. So let's look graphically at what this means. Independent equations, one solution. That just means that you have two lines. Let's say we have this line going this way and this line going that way. Here is our solution. There is one solution. There's an intersection point. Dependent equations mean there's infinitely many solutions. What we say is that all points on the line are the solution, because it's basically a same line. So if I gave you two of the same lines, basically, so if I have this line here and I have this line overlapping it exactly, that would be all points on the line will work for both those equations. And then finally we have inconsistent equations, which basically means we have no solution. We have parallel lines. So here's one line and here's another. They will never intersect, so we cannot have a solution. Okay. There are 5 methods we're going to be using. Actually, yeah, 5 methods right here. Today we're going to talk about graphing, substitution, and elimination. Tomorrow we're going to talk about, or the next video we'll talk about Cramer's rule. And we'll get into inverse matrices later. Alright, so substitution. Substitution is where you solve for one variable in one of the equations and then plug it into the other. You guys should remember this. I always look for something that is isolated by itself. Notice that this x is by itself. So I'm going to solve this equation for this x. So I'm going to say this is x equals, because I'm going to subtract 2y. 2 minus 2y. So I just solved that equation for x. What I can do with that now is plug it in to the second equation. So my second equation becomes 5 times our x is now 2 minus 2y minus 3y equals negative 29. And now you just solve it. 10 minus 10y minus 30y equals negative 29. You get 10 minus 13y equals negative 29. Negative 13y equals negative 39. So y should be 3. Now the nice thing is, you already have an equation for x right here. We know y is 3. Plug it back in now to this x equation that you have, so you can get x. So that means x is equal to 2 minus 2 times 3. So 2 minus 6 is negative 4. So our ordered pair or solution set would be negative 4 comma 3. That is my answer. Okay, if I graph those lines and they hit, that's where they would hit. So real quick, steps for substitution again. You want to solve for the variable. You want to substitute, sub into other equation. C, you want to obviously solve for the variable you can solve for. In this case, we solve for y first. D, you want to plug that answer back into first equation. Again, if you need to see this, just pause the screen. Okay, you can pause the screen here to write those down. But those are the steps for substitution. Should be something that you've done already. My favorite is elimination. It just looks easier. I like doing it more. Basically, you might have learned this as either elimination or linear combination. And so let's see what we have here. We have 3a and 6a, 4a and 8, or 4b, 8b, 10, 20. So I want to choose to eliminate the a values, which means I need to turn this 3a into a negative 6, because what I like to do with elimination is add these together. We want one of these to cancel. So in order to cancel the a's, I'm going to multiply the top by negative 2. So my new equation, when I multiply everything, don't forget to multiply everything, this new equation is negative 6a minus 8b equals negative 20. So now I've done this one. When I add down, I get 0 plus 0 equals 0, because everything canceled out. 0 equals 0. Now, what does this mean? Well, this is a true statement. When you get a true statement with elimination like this means that any point will work, that as long as it's on the line. So the answer is all points on the line of 3a plus 4b equals 10 will work for this problem. Anything you pick that satisfies that one equation will work. Alright, and this is called a special case. So let's talk about the special cases we can see. For special cases, the variables will cancel. All of them will be gone. For example, in this equation here, my a's and b's were gone, and also the numbers. So your variables will cancel, and then if you have a true statement when that happens, like we did in number 1, the answer is all points on the line. And if you have a false statement, that means you have parallel lines and no solution. Okay, so let's look at number 3 then. And if you guys want, you can pause the video and try to do this one on your own first and see what happens. See if you remember how to do this. I'm going to try to eliminate the x's again. So, or the first letter again. Again, I want to get this to be a negative 6, so it cancels with the positive 6. So I'm going to multiply everything by negative 3. So I get negative 6x, a negative 9y equals a negative 45. This time what happens, I get a 0 plus 0 equals negative 35. This is a false statement. The variables canceled, false statement. That means I have parallel lines, which means I have no solution. Now, if you want to do elimination the other way, you can. You can do it when there's no canceling of variables either. It works just as fine. You can then solve and plug back in. Number 4, solve using any method. I'm going to use the graphing calculator for this one because it's easier to visualize when you have 3 different things. We need to find where all 3 of these things hit. So first of all, I'm going to turn all these into slope-intercept form. So I get negative y equals negative 3x plus 5. So that means that y is equal to 3x minus 5. That's one equation. This equation becomes 3y is equal to negative 2x plus 7. So I get y is equal to negative 2/3 x plus 7/3. And finally, this one here, I get negative 4y equals negative x plus 9, so y is equal to 1/4 x minus 9/4. And that would be that. So these are my 3 equations I'm going to plug into my calculator or graph, and it's always good to sketch the graph. Actually, you could probably graph these yourselves without even using the calculator, and let's do that. So minus 5, 1, 2, 3, 4, 5. Let me just make some grid marks here. Alright, so 3x minus 5 is right here, and it goes up 3 over 1. Up 3 over 1. So this is one line right here. That's the line at the top. Now I'm going to do a second line. 7/3. Well, that's a little bit more than 2. 2 1/3 is right here. So then you go down 2, 1, 2, and then over 3. 1, 2, 3. So it's about right there. So I'm going to graph this line here. And finally I'm going to do the last one, negative 9/4. That's a little bit less or more than 2. And then I go up 1. So here, 1, 2, 3, 4. So if I graph this line, so if you look at this, I have these 3 lines graphed. I want to know the solution that will solve all 3 of these lines. Well, if you look, they don't all meet at the same place. There's 3 different solutions depending on the system. So, in this situation, the answer is no solution. Because we do not have, we needed one intersection point for all 3, and we don't have that. So that is one way you can solve systems also. Graph them, see where they hit. And if there's 3 lines, they have to all hit in the same spot, and they don't. Okay, this one looks really complex. It's actually not. I have people every year do this the hard way and then get it wrong anyway. Here's the easy way. Instead of having 2 over x, let's rewrite this as 2 times 1 over x minus 5 times 1 over y. All I did was take the 2 and the 5 off of those fractions, which you can do. And this one I can write as 3 times 1 over x plus 10 times 1 over y. Because when you multiply those, they'll just go on top, equals 18. Now, instead of using 1 over x and 1 over y, the easiest thing is to change the variables. Let's say I'm going to say a is equal to 1 over x, and b is equal to 1 over y. So instead of 1 over x and 1 over y, I have a's and b's. So I'm going to turn this into 2a minus 5b equals 5. And I'm going to turn this into 3a plus 10b is equal to 18. Now we have a nice, easy system to solve. Alright, so what I would do here, probably elimination, and I'd probably do the b's, because they're all I have to do is change the top equation then to get this to a negative 10. Again, with elimination, you want the same number with a different sign. We already have the different sign. I'll just multiply this by 2, so I get 4a minus 10b is equal to 10. So that's now gone. I'm not using that equation anymore. So when you add down, you get 7a. Those cancel. Is equal to 28. So a equals 4. So that's what a equals. Now I plug that back in for b. 3a, 3 times 4 plus 10b equals 18. 10b is equal to 18 minus 12 is 6. B is equal to 6 over 10. Remember, you divide, the 10 goes under, or 3/5. Now, we're not done yet though. We can't have our answers as a's and b's. We have to have them as x's and y's. Well, we know that 4, or a, is equal to 1 over x. So basically, when you cross multiply or flip it, multiply both sides by x, divide by 4, you get x is actually equal to 1 over 4. For this one, all you have to do is flip the fraction is what happens. It's basically the reciprocal. So that means y is equal to 5/3. So my final answer would be 1/4 for x, 5/3 for y. Okay, again, plug in a and b instead of the 1 over x, 1 over y, solve, and then basically you flip them for the final answer. Alright, we'll do some practice on that. That's in worksheet 0.5 for you. Alright, solve this by graphing. Let's do that real quickly. So, we have this line. Let's solve it. Negative 3y is equal to negative 2x plus 1. So I have y is equal to 2/3 x minus 1/3. That's going to be a little hard to graph. And this one just turns into y is equal to negative x plus 3. So these are the two lines that I'm graphing. Alright, so I'm going to scroll down a little bit. And I'm at plus 3 for this one, and it's a negative x. So that point goes there, that point goes there, and so on and so forth. Now when we're solving, I like to plot all the points just so I see where they might hit. Because if you just draw a line through like one point, it might not look as good, or you might not see exactly where they're supposed to hit. Alright, this is the one that's going to be a little tougher to graph. We have negative 1/3 and it goes up 2 and over 3. So negative 1/3 is about right here. And it goes up 2, so here, here, 1, 2, 3. And then 1, 2, 1, 2, 3. So something like that. So when I graph this, you should clearly see this intersection point. And what it looks like is it's at 2, 1. So that should be my solution set. Well, here's an easy way to figure it out. If you put 2, 1 in, like up here, if you put a 2 in for x, 2 times 2 is 4. So 4/3 minus 1/3 is 3/3, which is 1. That checks out. If you put a 2 in for x here, negative 2 plus 3 is 1. That checks out. So negative 2, 1 works for both equations. And you could also use your calculator to do second trace 5, which we did before, to find the actual solution. Alright, now, last thing, word problem. Write a system of equations and use it to solve the following problem. You plan to work 200 hours total babysitting and mowing lawns. You need to make a total of $1,300. Whenever you write a system of equations, you have two equations when you're dealing with this. You have the number of hours you're working and the cost for the problem. So I'm going to say that mowing lawns is x and babysitting is y. I know that, and this is going to be mowing lawns, the number of hours for both, number of hours. So my first equation is, well, we know that x and y have to add up to 200 hours. So x plus y, 200 hours. It says babysitting, which is the y, pays $6 per hour, and lawn mowing pays $8 per hour. So we know that 8x and 6y we want to be up to $1,300 for the summer. So this is my system of equations right here. Okay, here's my quantity equation, here's my cost equation. You always have one of those when you're dealing with things like this. Alright, so now let's solve this. The easiest thing is to get rid of the x or the y. I'm going to multiply everything up here by negative 6 and get rid of the y's. So I have negative 6x minus 6y equals negative 1,200. When you cross these out, you get 2x is equal to 100. So x equals 50. Which means that if I plug that back into my first equation, 50 plus y equals 200. Y equals 150 hours. So what that means is, it's always good to rewrite your final statement. Look back up at the top. In order for this to work, you will spend 50 hours mowing lawns, and you'll spend 150 hours babysitting. Okay, so again, this is important for coming up with the equation. The solving shouldn't take that long. But again, go back through this, try to set it up yourself again, or understand why. Again, you have to be careful with the 6 being with the y, because this is babysitting, and 8 going with the x. Alright, we are done.